All right, on to pretty much the last important part of Unit 6. So actually, I'll probably take a quick look at the last part. But standard deviation is another measure of spread. So we talked about central tendency, mean, median, mode. That's the stuff, like, I don't want to use the word middle, but that's central data, right? So we got the average, we got the middle, we got the most common, and that's how we've described data in the past. One way to describe data in a different sense is through spread. So we talked about that yesterday, looking at the box and whisker plot. That kind of showed, well, first of all, we did percentiles so we could figure out where data is, where are you ranked in data, right? So percentiles are used to give a rank of some sort, right? So again, if we talk about like grades, if you're in the 33rd percentile in your class, that means you've only beaten 33% of the kids, okay? So 67% of the kids, give or take a little bit, are higher than you as far as the mark goes. If you're in the 88th percentile for speed, you're fast, okay? That sort of thing, okay? So that was that. Then we went back and we looked at quartiles, and quartiles helped us make a box and whisker plot. And the box and whisker plot talked about spread depending on how long and how wide those box or whiskers were. Another way to talk about spread, and the most common way to talk about spread, is this, standard deviation. So we look at some examples here, and I'm going to kind of zip through this, but these are the formulas, which I'll get back to later. Two different formulas here, one for variance, for population variance, one for sample variance, one for population standard deviation, and one for sample standard deviation. Slight difference here is, are you doing n minus 1, or are you just using n? Are you like for the sample, you're going to subtract 1 in both cases here. These equations are useful, but I don't use the equations all that much. We use the table. Okay, so to find standard deviation, what you're looking at here, and we're really going to analyze standard deviation and what it means in the next unit. But this unit, I want to be able to figure out how to calculate standard deviation. So what we're looking for is we're looking at the spread of the data. So basically, you have, if you look how this is made up, right? What you're doing is you're looking at the difference between the average and a point. Okay, so you have the average and a point, and you want to know what's the distance between those. The bigger the distance, eventually the bigger the standard deviation. We square the data. The reason we square the data is if I said to you, I have 10, let's just say I ate 10 cookies, and I ate 10 cookies, and I ate 10 cookies, and I said to you, okay, that's what I did in one three day period. And then another 3-day period, I ate 10 cookies, I ate 20 cookies, and I ate 0 cookies. So the mean is still the same. The median's the same. There's no mode here, but let's pretend there was. Anyway, it doesn't matter. If the mode was 10, the central tendencies aren't telling us any data here. We want to talk about spread. These are not the same 3-day periods, right? This is a consistent cookie day, 3-day period. This is all over the place. So what you want to do is look at the distance between the average and each point. So if the average is 10, which it is, the distance between here and 10 is 0. And the distance between 10 and 20 is 10 plus 10, right? So I ate 10 extra cookies this day, and I ate minus 10 extra cookies the next day. Okay? Or 10 less cookies. Minus 10 extra cookies. 10 less cookies. So let's go over that again. Each day it's the same. Okay? Each situation I have the same average, 10, 10, 10. But here, when I'm looking at the distance from each day to the average, that's plus 10, that's minus 10. If I just added those up together, what I'm going to end up is 0. I'm going to end up with 0 because if I take all the averages, or the distance from the average, that's how you kind of get the average, right? Is you get in the middle from the data points. So what we do is to get rid of this negative here is we square it. Okay, so if I square this would be 100. This would be 100 also. The key is not the size. We're not worried about the numbers so much as the fact that we want these numbers all to be positive, because we're going to we don't worry if this is 10 cookies and that's 20 cookies and that's 0 cookies. I don't care which direction that's in. This is the negative direction, this is in the positive direction. What I care about is the distance from the mean. So the bigger the distance from the mean, so at other days, if I had 10, then I had 21, and then I had 3, and, I keep doing this sort of thing, I would have all these different distances, right? And I don't care, are they in this direction or that direction? I care about how big the distances are. So that's why we square, okay? You don't need to know all that. You just, right now, we'll get into how that works later. What we're going to do is look at this example, and this will sum everything up. You got this group of kids, they're a basketball team. You quickly take a look at this. The mean, the median, the mode. I didn't write them down here, but they're about the same. Okay, they're all about the same. They're in the 160s. But but if you look at these two teams, regardless of if you think one team is better than the other or whatever, what the key is, these kids are the same height. They're about the same height. There's not much difference. I have a total range of 7. There's the smallest, there's the biggest. Okay, there's my total range. If I was to look at this on a little chart, it'd all be like this, very similar. Okay, these guys are all over the place. I got a 146. I got a 183. Okay, I got big kids, short kids. I'm all over the place. Where are they? I don't know. But I don't have, if I look at mean, I look at median, I look at mode, I don't have a number that's going to tell me that these guys are spread out compared to these guys. Standard deviation does that, and we're going to show you how to do that. So what you do is first you find the mean of the data. So I'm going to go ahead and just find the Falcons. Look at the Falcons. If you add all these up and divide by the number of elements, you get a mean of 165. Okay, there are 7 kids on the team, so that's your mu or your mean, and that's your n, which is 7. So what you do is you take all the heights and you write them down. Okay, 183. These are just all the heights from here. Okay, so I go from Laura all the way to Sheila. That's their heights. And what you do is you take the height and you subtract it from the mean, and then you square it. So I go 183, subtract 165 squared. Okay, so I get that number and I square it, and then I write that down. Then I go 165, subtract 165 squared. So that just happens to be 0. You don't need to do all this. So when you do this, what I would do is grab your calculator. So I'm just going to grab my calculator as I do this. Okay. So grab your calculator, and then I'll do this one right here, 146. So I go 146, subtract 163 equals, that's 17. It's negative 17. But I don't need to write that down anymore. All I have to do now is take that 17 and hit the squared button, and then I get not that answer. This is entertaining. 280. Oh, sorry. I'm sorry. 148. Sorry, this one here. 289. Okay, that was interesting. Okay, so that's how you get this number. Let me try that again. For this one here, 146. So if I go 146, I think I just combined 2 lines at the same time. So if I go 146, subtract 165 equals, I'm gonna get 19. I just don't write that down. Don't write 19 anywhere. Don't even write this down, really, guys. What I'm gonna do here is go like this: x minus mu squared. Just put that there and give me these numbers. So 146 subtract 165 is 19. I square it, I get 361. Write it down. Write this down. Write that down. Write that down. Add them up. That's your sum, 1520. 1520 is getting me there. That's the total of the squares. So that's, if we go back to this equation, that's the sum of the distance from the square, the square of the distances. Okay. So I go here. Sorry. I go here and I get the distances and I square them and I sum them up. So that's going to give me that. Okay. So that's that part of the equation. Again, you don't need the equation for this. I use a table. I think it's the best way to do it. So you do this, you add them up. There's your sum. To get the variance, that says variance VAR, you take the sum and you divide by n. So 1520 divided by 7 is 217. To get the standard deviation, or the sigma in this case, at small s, if you're using just a sample, doesn't matter. Then you take the root of this and you get 14.7. Okay. Next unit, we're going to talk about what the 14.7 means. We don't care too much about it. I don't want to say don't care, but we don't care that much about it. All I want to do is, there's a number. It's 14.7. That represents spread. If I was to do, and you guys are going to do it later, we'll do it in class, this group of kids, they would have a standard deviation of, I don't know what, but it would be smaller. Let's say it's 3.3. I can't remember what it is. Let's say it's 3.3. I would have sigma this and sigma that. Standard deviation here, standard deviation here. This stuff is more spread out than this stuff. That's all we're doing right now. If you want to know a little bit more, it's all down here, okay? But you don't need to know this now. That's the whole next unit, okay? So just standard deviation, this is how you do it. Bigger standard deviation means more spread out. Smaller standard deviation means less spread out. If we go back to normal distributions, we're talking about the distributions. If that's group 1, group 2 might look like that, okay? Bigger standard deviations, more spread out. Smaller standard deviation, less spread out. Lastly, just look at this stuff, multiple bar graphs. We're not getting into this too much, okay? Just ways to look at data. I will look at population pyramids in class with you guys, talk about those. That'll be straightforward though. So I don't think we need to go over that. Okay, just know how to do standard deviation at this point. Next part, we're gonna mess around. Oh. The mic went down. Who knows what happened? Can you hear me? I'm fine, just in case you're worried. All right, that was interesting. All right, see you. Bye.